Okay, so now our FEA simulation is completed. Just quickly before I move on to explaining these results, I made a slight mistake in the component interactions. So if we have a look at the interaction where we had all our bridge members bonded, this gap range for bonding, you'll need to change it to 0%. Cool, so here we have our result. This is our stress contour plot, which is showing us this deformed state, which is quite exaggerated, and the scale is at the top here. And we can also turn on and off the deformation. And what we could do as well is we have a few plot tools up the top here where we can cut sections of our model and have a look at the contours in there. But we also have this probe tool which can come in handy, so we can just click certain points and it will give us which node we're looking at, the XYZ location of the node, and the value corresponding to the result that we're looking at. So right now this would be the stress at that point, and you can select multiple points at once. Now let's take a look at these results. So if we right click on that, on stress 1, and go to edit definition, we can have a look at the different settings we have in here. So we can display the different kinds of stresses: normal, shear, principal stresses. So we'll just leave this at von Mises for now. And here we can change the display unit. So this would be in Pascal, and there's also the megapascal here. This is a shell face, but we can leave that as top for now. And here we have the settings for the amount of deformation, or the deformation scale. We can just leave that as automatic, or we can use the true scale or our own scale. Automatic is fine. Here under chart options, we can show the minimum stress location or even the maximum as well. And here we can change the units or the decimal places for our legend, as well as the type of number settings, so either general, scientific, or floating. And there's a few other options. We can change the colors and such, but I will let you guys explore that. And the same here, we don't really need to touch any of these settings. The same goes for the displacement, so we can have a look at the definitions here. We can change the units from millimeters to meters or centimeters or whatever we want. Here we'll take a look at this shortly, but right now we're displaying the resultant displacement based on all the three directions, X, Y, and Z. However, we may be interested in just the displacement in one direction, so we'll have a look at that in a second. Of course, we've got our deformed shape scale, and of course the maximum displacement areas or minimum, and our numbers settings. And the same settings sort of apply for strain as well. So what we can do now is we've got our resultant displacement here. Let's right click on results and define a new displacement plot. We'll leave this on millimeters, and instead of resultant we're going to choose displacement in the Y direction and confirm that. We'll probably also change our deformation scales, so let's make this automatic for now. And now if we have a look on the YX plane, we can see the Y deformations here. Now, because the deformations are in the negative y direction, the blue areas are actually where we have the highest displacements in the negative direction, so the lowest displacement. We can actually flip the color scale if we'd like to in the settings, but we can leave that as is. And up here we can even just turn off the deform result as well and have a look at that. Then we can use our probe tool to see the Y displacement in the middle of the bridge here, and there we have the value. So that's pretty, that'll be useful in your report or your final presentation. Now there's another result we want to create here, which is very important. So if we right click results, we can select this define factor of safety. And so now we need to choose what bodies of our assembly we want to include in our factor of safety. Since we're not looking at the road at all, we want to exclude that. So we'll choose selected bodies, and then from our tree here, we'll choose the all of our parts here, but we'll exclude the road. And then this is the criteria for the factor of safety, and we'll just choose the von Mises stress and confirm that. And so that gives us our factor of safety plot. So the dark blue areas are where the factor of safety is very high. So that's not